Have you looked at your curtains on a sunny day and noticed that it's almost transparent? That's light passing through. Light comes in many colors, like in a rainbow. Red, orange, yellow, blue, violet. But did you know that there are some colors our eyes can't see? Beyond the rainbow, there exists a very special type of light called X-rays. Regular light, like those coming from a lamp or a sun, can go through very thin things, like paper and your curtains, with ease. But it can't go through very thick things, like your body. That's why when you walk outside on a sunny day, you have a shadow. But X-rays, they're special. They can pass through many things very easily. When shown at your body, they can go through your skin, your clothes, and your organs. But they can't go through your bones. Because of this, in hospitals, doctors use a machine to take pictures with X-rays, and it helps them check your bones for problems without having to cut you open. Similarly, doctors use many machines like these to be able to understand what's going on inside your body without having to look inside directly. Now you know how X-rays work. Hey young scientists, today let's dive into the fascinating world of X-rays. First, a quick refresher. Everything around us is made of atoms, and these atoms have even tinier parts: protons, neutrons, and electrons. Electrons whirl around the nucleus, which is made of protons and neutrons. Now, on to light. Light is made of tiny packets of energy called photons. These photons have different amounts of energy, creating the spectrum of light that we know. But beyond ultraviolet, there's a very special type of light with even more energy: X-rays. Because of their high energy, X-rays can interact with the electrons in an atom. When X-rays hit an object, like our body, several things can happen. Some X-rays simply pass through, especially in gases or soft tissues. But some X-rays get absorbed or scattered by denser materials, like our bones. But why? It's all about electrons. The high energy photons in X-rays are able to pass through very less dense objects like your organs, because since the atoms are more spaced out, they're able to knock electrons out of their orbits around the nucleus. Denser materials with more electrons absorb X-rays. This is why bones, which are dense with calcium atoms, appear white on an X-ray image. This is why, after they take an X-ray of your body, the bones appear white since it's absorbed all the rays, but your flesh is a lot darker since it let all the rays pass through. Doctors can use this image to understand what's going on within your body and determine whether there is a fracture of your bones or some dislocation. Similarly, ultrasound and CT scans work on the same principles, which allows doctors to be able to understand what's going on in your body without having to actually peek inside. Welcome budding physicists and future medical experts. Today, we're journeying into the physics of medical imaging, starting with X-rays. X-rays, like visible light, are part of the electromagnetic spectrum. But what sets them apart is their wavelength, typically between 0.01 to 10 nanometers. This short wavelength is accompanied with high photon energy, thanks to the inverse relationship between energy and wavelength as described by Planck's equation. When X-rays encounter matter, several interactions can occur. One primary interaction is a photoelectric effect. Here, an X-ray photon is absorbed by the atom, completely ejecting one of its inner electrons. The energy of the incoming photon must be greater than the binding energy of the electron for this to occur, and this is why this mainly happens with X-ray, which are high energy, and not with light. The Compton effect is another significant interaction. Here, instead of the photon losing all its energy, an X-ray photon scatters off an electron, losing some of its energy instead and changing direction. This scattering contributes to the contrast that we see in X-ray images. This is why, after they take an X-ray of your body, the bones appear white. The bones absorb all the X-rays due to the photoelectric effect and doesn't let any of it pass through. Your flesh is a lot darker since it lets a lot more of the rays pass through. Beyond X-rays, the realm of imaging is vast. CT scans take many X-ray pictures from many angles and reconstructs it into a 3D image. MRIs and ultrasound also work on similar principles. Thank you.